Hello friends, welcome to our science channel CBSE Science Lovers. So today we are taking one important topic. So friends, in our previous video we have discussed a little about the matter. What is the matter and what are its physical states? So after the physical state, now we will discuss in this video that how the physical state of the matter decided, how the physical properties of the matter decided the physical state of the matter. So basically, states of the matter in which a matter exists. Now we have discussed that states. Generally, the matter has the three physical states: solid, liquid as you are seeing, and my dear friends, gases in which we are, that is atmosphere. So basically, these three physical state and another physical state which are recently discovered, that is the plasma state. Also, we will discuss a little bit on the plasma state. Otherwise, other physical state of the matter also be there, but their existence is at an extreme conditions like very low temperature and high density. So in general, around us we have seen three basic physical states, that is your solid state, liquid state and gaseous state. So students, how the different physical property decided the physical state of the matter. Let's discuss. So, if you see the particular arrangement in the different physical state, in solid state, in liquid state, and gaseous state, so see the particular structure. Particular structure in solid state. Here you are seeing all the particles are compactly arranged in a particular structure. See, here all the particles are compactly arranged and providing a particular shape, particular size to the solid material, solid matter. So we can say that in the solid, all the matter particles arranged in compactly in a particular order. Whereas if you see the liquid state, in the liquid state, all the particles are arranged orderly, but they remains in the system and they are free to move in the system here and there. With comparison to the solid, just if you compare the solid, in case of the solid, particles do not move, do not replace their position, they only vibrate. But in case of liquid, matter particles can move in the system, but they do not release the system. So they have the interparticular energy, we can say, comparatively higher with the solid state. Matter particles collapse to each other, they moves randomly in any direction in the system and collapse to each other. So my dear student, that is the reason that the liquid phase of the matter has a particular volume but do not have a particular shape. Just to see this liquid phase, when it is, this liquid is in this container, it takes the shape of this container, and when you drop it into another container, it's take the shape of another container. It means that in the liquid phase the matter has a particular volume but not the particular shape. In case of solid, solid has a particular volume as well as a particular shape. Why? Because this, in case of solid, all the matter particles are compactly arranged. If you go to the gases, then gas particles in the gas physical state, all the matter particles are randomly moves here and there, and they vibrately, they randomly can release the system also. So they have no particular shape and size, and they also have not the particular distance in between them. They moves here and there randomly, and they release the system also. Just here you are seeing that in gas phases, the particles releasing the container also, they release the system. So these are the three physical state in which we have seen that in all physical state, the particular properties, the physical properties in different physical state vary. Means there is the variation in particular structure amongst solid, liquid, gas. There is the variation in between particular space. There is the variation in between interparticular forces. Interparticular energy also show variation in between solid, liquid, and gases, and compressibility and diffusibility also. So let us see on the basis of the physical properties how the solid, liquid, and gases are. Just if you see on the basis of the particular spaces. So my dear student, if you go to the solid phase, so in the solid phase, all the particles are arranged compactly. So very less particular space in between them. Very less particular space in case of solid. When you go to the liquid, then comparatively more particular space with the solid phase, but less particular space when you compare the liquid to the gases. In the liquid, the particles are comparatively far away to each other in case of solid. And if you see the gases, particular space is more. So if you see on the basis of the particular space amongst the solid, liquid, gases, so in the solid there is very less particular space in between the particles. In liquid phase, comparatively more interparticular space with the solid, and comparatively with the gas there is less particular space in case of liquid. If you see the gas, so in the gas physical state, there is the maximum particular space in between the particles in these matter phases. So dear students, if you take the another character, interparticular force. So in case of solid, what is the amount of interparticular force? So if you see, in case of solid, all the particles are compactly arranged due to the high interparticular force in between them. So interparticular force in case of solid in between the particles is very high. In case of liquid, comparatively less. Means if you compare the liquid from the solid, then is the comparatively less interparticular force, but it is sufficient to hold the particles in the system. In case of solid, all the particles tightly packed due to the high interparticular force in between them. In case of liquid, this interparticular force comparatively less, but it is sufficient to hold the particles in the system. But in liquid, the particles moves in the system and they collapse to each other, but they do not escape the system. If you see the gas, So in gas, very less interparticular space. So on the basis of the interparticular space, if you classify, if you kept the physical state in an increasing order, then gas, after the liquid, and then solid. It means the higher particular force in between the particles in case of solid. After that liquid, after that gas has least, and that is the reason in the gaseous phase the particular particles are free to move here and there. They are not held in the system. They moves freely in another system. And if you see interparticular kinetic energy, so my dear student, in the solid phase there is very less interparticular energy, and due to the less interparticular energy in the solid phase, the particles just only vibrate. They do not overcome the interparticular force in between them. If you see the solid phase, so there is the interparticular force, and they do not overcome this force because of the less kinetic energy. And if you see the liquid phase, comparatively more kinetic energy from the solid, means very less, then comparatively more. And if you goes to the gas phases, then high interparticular energy, and due to the high interparticular energy, particles moves randomly here and there, and they escape the system. They overcome the interparticular force in between them. So the next, compressibility. Compressibility, student, what is compressibility? Compressibility, when you apply an external force on the matter, then matter start to mold its shape, start to change its shape and size. That is compressibility. Means the ability of the matter to mold after applying an external force, that is said to be the compressibility. So if you see the compressibility among solid, liquid and gas, so solid has very least compressibility. Means if you put any external force on the solid phase like that, I am compressing it by putting the external force, but it is not changing its shape and size. It means solid phase is very least compressible. Then go to the liquid phase, the compressibility comparatively more. Comparatively more than the solid phase. See the liquid phase, you can compare. You can compare the liquid phase. So the compressibility, but you cannot just change the size, just change the volume of the liquid. So compressibility comparatively with the solid is more, but comparatively with the gas, less compressibility in liquid state. And when you go through the gaseous state, then gases are highly compressible. Highly compressible. Gases are highly compressible. Just I am demonstrating the gas phase. So see the dear student how the gaseous phase is highly compressible. Just this is the visible form of gaseous physical state of the matter. See how this gas particles randomly moves here and there in the environment of this room. See, this is the gaseous phase, and how much fast these gas particles moving in the system. So what we can say, it is highly compressible. So due to the high compressibility of the gaseous phase, gas can be kept into a small container. A large volume of gas can be kept in a small container like our LPG used in the kitchen for cooking, that is also compressed and kept in the cylinders. CNG, compressed natural gas also. And nowadays you are hearing the oxygen cylinder coming हो रही है, oxygen cylinders की due to the corona situation. So in oxygen cylinders also oxygen gas is formed highly compressed so that a large volume of the gas can be kept in small container. So that is the compressibility which makes this storage facility of the gaseous physical state of the matter. Now see diffusibility. As in our previous video, I told you that what is the diffusibility? The intermixing of the two matter particles is said to be the diffusibility, or you can say that bidirectional movement of the two matter particles is said to be the diffusibility. So the diffusibility in case of solid is very least. In case of solid physical state, the diffusibility is very least, but diffusibility is there. How you can say that? Just अगर मैं इस लिखावट को ना मिटाऊं for a long time, then it is very difficult to dash out this written content from this board. Why? Because this ink particles diffused in the matter of this board, that is solid diffusibility, but it is very least. So comparatively, if you see the diffusibility character in liquid cases, then it is comparatively more. Comparatively more in case of liquid with comparison to the solid, and compressibility is very high in case of gases. So these are the different physical states, my dear students, and these physical properties decide the physical state of the matter. As you can see, the particular space is very less, and it is comparatively more particular spaces in case of liquid. Then in case of gases, particular space is very high. Just if you see the interparticular force, it is very high, just reverse condition. In liquid case, comparatively less from the solid, and in the gases it is very least. So these are the different physical states. So you can see different physical states. See the student, diffusibility. These gas particles randomly diffuse in the air of this room rapidly. So we can say that diffusibility of the gaseous phase is very much fast with comparison to the solid. We can just take the fragrance of hot cooking food from our kitchen by upward descent due to the diffusibility of the gaseous particles. So these are about the physical state of the matter. If you see the plasma, so my dear student, plasma is a special recently discovered physical state in which all the particles are arranged in such a manner that the total matter becomes neutralized. So plasma is totally neutralized phase of the matter. So dear student, today we have discussed different physical state of the matter. Now one question is coming in our mind. एक क्वेश्चन आ रहा होगा हमारे दिमाग में बच्चों, can these physical states be changed to each other? Can solid be changed into the liquid, or liquid be changed into the gases, or vice versa? Gases change into the solid, liquid and solid. So this is said to be the interchange of the physical state. Is it possible or not? तो इसका उत्तर जानने के लिए बने रहिए आप हमारे साथ, हम आपके हर प्रश्न का उत्तर देने को हैं तैयार। In our next segment, we will discuss that how the different physical state of the matter interchanged from one phase to another phase. For that, बने रहिए सीबीएसई साइंस लवर चैनल के साथ और पूरी करिए अपनी जिज्ञासा। थैंक यू, हैव अ नाइस डे।